Does anybody remember how to work with a rational expression? So it's like 64 to the 1/3. So the denominator is the root, and the numerators are the power. And so this would be the cube root of 64 to the first power, which is 4. Yeah, so 64 is 4 times 16. And so we have a set of 3 things, and so we end up with 4. So that's one way we can handle this. Most of these you can handle a couple different ways, so I'm going to be showing a couple different ways because it's good to know both ways. So another approach here is to recognize 64 is 4 to the power 3. So if I have 64 to the 1/3, I can rewrite 64 as 4 to the power of 3 to the 1/3 power. And then with rules of exponents, what do we do with the 3 and the 1/3? Multiply them. And so we get 4 to the power of 3 over 3, which is 4 to the power of 1. So again, we can get the same answer by changing it into a root form, or just by working with the exponent. Number 2, we have -2 to the 2/5 times -2 to the 3/5. What do you remember? You add what? The exponents. So the 2/5 plus the 3/5. And then what do we do with the -2's? Okay, so we refer to that as the base. And so does the base ever change when you're working with the exponents? So keep it the same. So this is -2 to the power of 2/5 plus 3/5. And 2/5 plus 3/5 is 5/5 or 1. And so you end up with -2 as an answer. Anybody see anything wrong with that though? And it might be hard to catch if you're just working in this form. What does -2 to the 2/5 mean? It's the 5th root of -2 squared, and the 5th root of -2 cubed. And so this would be the 5th root of 4. No problem there. But the next one would be the 5th root of what? -8. So anybody see an issue? Are we allowed to do that? If the root is odd, are we allowed to do that? Yes. Okay. So there is no issue. So we can keep going. Yeah. We're allowed to have a negative there. Now, if this was even, would there be a problem? Okay. So in this case, there's no problem. But if I had an even denominator, and you could work through this and just bypass the fact that you may be doing something illegal because you may be working with the square root of a negative and those kind of things, right? So this would be the 5th root of 4 times -8, which is -32, and that's going to be -2 as well. So 11 to the 1/2 times 11 to the 1/2. What's the answer going to be? 11. And again, you can do this 2 ways. You could say that's the square root of 11 times the square root of 11 and get 11. Or you could add your exponents, 1/2 plus 1/2, and get 11 to the power of 1, which is 11. Okay. so on number 4, we have 3 to the 1/2 times 12 to the 1/2. If the bases are different, but the exponents are the same, can we simplify that any further? So what does 3 to the 1/2 mean in terms of if we changed it to radical form? Square root of 3. And this would be the square root of 12. Can we multiply those together? So that would be the square root of 36, which is 6. So it can be simplified even if the bases are different. If you can get the exponents to be the same, then you can put everything under the same roof. Okay. Negative 27 to the 4/3 power. Go ahead and get an answer to that one. Diego, did you get an answer? Yeah. Yeah, almost. What are you trying? Cube root of, so you're going 27 times 24 of them? And the e, okay, so they're all negative, but it doesn't matter because any negative to the 4th power is going to be positive. Okay, and so you're trying to break that down and see what you end up with? Okay. Can we do this? Can we say, okay, I got 3 27s and grab those? And then we got 3 3s. So we're going to get 27 times 3, which is 81. So that's one way, and it certainly works. But there are a couple other ways. Did anybody do it a different way? Chase, what'd you do? Okay, so I'm going to rewrite it. So I got negative 27 to the 4/3, and you change that to negative 3 to the 3rd to the 4/3. So we're just changing the negative 27 to negative 3 to the 3rd. Okay. Multiply those exponents, and you get negative 3 to the 4th, which would be positive 81. And is there another way to do this one? Oh, question. Yeah. Well, if you have 4 negatives that are multiplied together, you're going to get a positive answer, so we ignored the negative. Yeah. Oh, so you're referring to like what we did in the first one? Or so you had something like this and you just broke them all up and saw how many different negative 3s we have. Okay, there's one more way to do this. And if you move this to a cube root, you can also rewrite this as the cube root of negative 27 only, and then raise that to the 4th power. So you could put your 4th power on the inside of the root or on the outside of the root. And often if you put on the outside of the root, it's easier to work with if you have a number, because it's easier to take the cube root of negative 27 than negative 27 times negative 27 times negative 27 times negative 27. So if I did this, I'd get negative 3 to the 4th, which again, we're getting 81. So you don't have to do it 3 different ways, but knowing how the 3 different ways work gives you some more ability as you have different kinds of problems and different approaches to take. Okay. So number 6, we have 5 to the power of square root of 3 to the power of square root of 3. What's that going to equal? So you multiply the roots, and you get 5 to the third, 125. And that's the only way that I can think of to do that problem. Okay, there's no, you can't change that one into radical. Okay. No fraction. So part of this is just to be able to go back and forth between the forms. And so this next section here in our notes, I want you to go from one form to the other. And we're going to write each expression in radical form. So number 7, what's the root going to be? And then, so the 8th root of w, the 5th. And so that would be acceptable. Or you could put the 8th root of w and you can put the 5th on the outside. If we have a variable, we tend to put the exponent on the inside, the first way, but both are correct. Try 8. 8, you have a negative exponent and you have a fractional exponent. You're going to have to work with both. And remember, we can't have any radicals in the denominator for your answer. You guys remember what to, or have an idea what to do on that? With the negative exponent in the fraction? We first get rid of the negative. How do we get rid of negative exponents? Move it to the other side of the fraction. Right now this is over 1 if we were to write this as a fraction. And so we can rewrite this as 1 over t to the 2/3 power. So if you have a negative exponent, deal with that first, then get rid of the fractional exponent. And so this means 1 over the cube root of t squared. So now it's in radical form, but we need to simplify that radical form. And how do we get rid of that cube root in the denominator? Multiply by cube root of t over cube root of t. And we're going to end up with the cube root of t over the cube root of t cubed, which is just going to be t. If you have a decimal as a exponent, change it to a fraction. Okay, so 2.6 is the same as what fraction? Okay, and before you got 13 over 5, what would you have? 26 over 10, right? So 26 over 10, and then you can reduce that fraction to 13 over 5, and then it's just like number 7. 5th root of y to the 13. But we shouldn't stop there. Why not? If you have more than, you got to simplify your radical. So we have 13 y's, and we got to pull out sets of 5. So how many of those 13 y's can we get rid of? 10 of them. We're left with 3. And so we end up with y squared, 5th root of y cubed. So that's going from exponential form to radical form. The next 3, I want you to go the other direction. So I'm going to give you radical form, put it into exponential form. Luis, what would the answer to 10 be? Yeah, number 10. X to the what? 3/4. Good. Okay. Number 11. 10 to the 1/2. 12. 2ab to the third, like that, in parentheses. Okay. And so if we simplify that further, if we get rid of the parentheses, what will it end up being? 2ab cubed, like that. Yeah, okay. You got to cube everything, right? So 8a cubed, b cubed, right? All right. So it's a little easier going the other direction. Right. So these next ones we're asked to put in simplest form, and it could be in radical form or it could be in exponential form. We just want to simplify it as best we can. So if it doesn't specify which form, doesn't say radical or exponential, we have the freedom to go either. And so for each of these, let's give both forms as an answer, and so we know what they'd look like. So 13, we got square root of 3 times the 4th root of 3. Can I multiply those together? No, one's a square root, one's a 4th root. You can't multiply things that have different roots. So we need to create the same kind of root in order to do that. Can we turn a square root into a 4th root? Like, can I? So I want to work with. This is a 4th root. Can I change the square root of 3 to the 4th root of something? What would it be? So we know that the square root of 3 is 3 to the 1/2. I'm just going to leave this on the 4th root of 3. In order to make this a 4th root, I needed my denominator to be 4, right? And so can I change that 1/2 to a fraction over 4? What would the fraction be? So this is 3 to the 2/4. So if I wanted to keep it or rewrite it as a 4th root, this would be the 4th root of 3 squared times the 4th root of 3. And so you could change a square root to a 4th root that way. And then this is going to be the 4th root of 3 cubed, which is 27. We can also say, well, let's not work with roots. Let's work with fractional exponents. We could say, well, this is also 3 to the 1/2 times 3 to the 1/4. And base is the same. If the base is the same, leave it and add your exponent. So 1/2 plus 1/4. Again, you're going to have to get a common denominator. So you get your 1/2 to 2/4. You'll end up with 3 to the 3/4. And you can stop there as an answer. If you want to see the relationship between these two, you can even rewrite this as 3 cubed to the 1/4, which would be 27 to the 1/4. So all three of those would be acceptable answers. Okay. So on 14, I want you to get an answer in one in radical form, one in fractional exponent form. Trenton, did you get an answer? Okay. What are you trying? Which form are you going for? Radical form. Okay. Jonathan, you got an answer? Which? Give me one of the forms. Doesn't matter which one. Okay, and how'd you do that? Good. All right, so then 8, 6 plus 5, 6, 13 over 6. Good. Okay. And then if we were to write this in the other form, did you get an answer, Trenton? No. We can go straight from this form. This would be the 6th root of x to the 13. But then we'd have to simplify that further because we can pull out sets of 6 x's, right? And so this could be the 6th root of x to the 12th. So 12 is a multiple of 6, and we're left with one more x. So this would be x squared times the 6th root of x. So 15, try this again. We have a negative exponent and we have a fractional exponent. We want to simplify it as far as we can in both forms. And remember, if you get a fraction, you can't have a root in the fraction. And that means you can't have a fractional exponent in the denominator of a fraction either, because that would be considered a root. Is get rid of the negative exponent by putting this all beneath 1 in a fraction. So we get 1 over the whole thing, 5x to the 3/4 power. And that 3/4 power is a 4th root, so we can't leave that in the denominator, so we got to get rid of that. We can first change this. I'll put this below here. So 1 over 5 to the 4th root of x cubed. And then what will we multiply by to get rid of that 4th root? 4th root of x over the 4th root of x. And we end up with the 4th root of x all over 5x. So that's one possible answer. If we didn't change this to radical form at all, we could also solve this. What would we multiply this fraction by to get rid of the fractional exponent? X to the 1/4. Because when I multiply by that, I'm going to be adding 3/4 and 1/4, which would give me a whole number in the exponent and get rid of the fraction. So this would end up being x to the 1/4 over 5 times x to the, you're adding 3/4 plus 1/4, which would be 1. Question, yeah. So the 3/4 only belongs to the x. If the 5 and the x were both in parentheses together, then that 3/4 would belong to both of them. So here's another, like if I had 5, if I had this 5x to the 3/4, then I would have to say that's the 4th root of 5x, still in parentheses, cubed. So the 5 would be cubed and the x would be cubed. If there's no parentheses around things, then that exponent's only going to belong to whatever's right there. So in this case, it's just an x. Okay. 16, 17, and 18. Same deal. Try to simplify this as best you can. Let's look at 16. You got the square root of x cubed, over the cube root of x squared. So here we're stuck in radical form because one's a square root, one's a cube root. So the natural thing to do is to get it out of radical form. And you got x to the what? What's the numerator going to be? X to the 3/2, right? Because you got the power is 3, the index is 2. And then over x to the 2/3. When you're dividing and you have the same base, what do you do with the exponents? Subtract. So this is going to be equivalent to x to the 3/2 minus 2/3. And then you work from there, get a common denominator, which would be 6. So 9 over 6 minus 4 over 6, which is x to the 5 over 6. If you put that in root form, that would be the 6th root of x to the 5th. Next one's going to be very similar. It's a division problem. It's already in fractional exponent form, so we can just subtract our exponents. So 3/5 minus 4/10. What would be your next step? Y to the what? If you were working out that subtraction problem, what would you do? Reduce, yeah. So 3/5 minus 2/5, which is 1/5. Oops. Y to the 1/5. Or the 5th root of y. All right, again, try 18. Couple ways to do this, but 1/2 means the square root. So we can think of this as the square root of the whole thing. we notice we can reduce this fraction, the 50 over 18. And then everything ends up being a perfect square. So what's the answer? Okay. So there's easy routes on some of these and harder routes on some of these. So this one, that's probably the easiest way to go. Reducing fractions can help. Always look for that if you can reduce a fraction. We got one last problem here. X to the 1/5 times y to the negative 1/5 over x to the 1/2 times y to the negative 1/2. You're going to remember when you simplify this one, no radicals in the denominator, or no fractional exponents in the denominator.